All right, y'all. Today's notes are going to be really quick notes, and a lot of it should feel like review, but basically it's going to be focused on kind of getting us used to seeing different kinds of like data distributions um, that may show up on your SAT, so that we're comfortable when we see them and we know how to read them, and then also finding mean, median, and mode. Um, and understanding just like where those fall on data on the depending on the shape of data. Okay, so at first, it would be nice if y'all just follow along with this first part. You don't need to necessarily take notes on this, but you do need to be familiar with all of the things we're going to be talking about. I'm sure y'all have used these in the past, but if you're not familiar with one thing, it may be worth writing down just a quick note to yourself so that you can remember what these are. So first we're going to talk about frequency tables. Frequency tables, these show up on the SAT a decent amount. It'll be a table, kind of like this one down here, where the data values are showing up in one column. So data values in one column, that would be like this column. We have a bunch of data values. So these are test scores. And then the frequency in the other column. And just a reminder, frequency means the number of times a data value occurs. So for this example, you can see that there were 6 students. There were 6 tests with scores from 91 to 100. So the tough thing about the frequency table sometimes for students is when you're finding the average or the mean, you have to remember to use the frequency when you're finding that average or mean. Okay, histogram. On to histogram. This displays large amounts of group data and is very similar to a bar graph. So you can see a histogram down here. This is actually the same data as before, so we're talking about test scores again. And you can see like this data, 91 to 100, there were 6 students who scored that. Over here we have 91 to 100, and you can see that that lines up with the 6 number of students who scored that. An important thing to note on histograms is just make sure when you see a histogram or a bar graph even on the SAT, make sure you read your x-axis and what it means. So like the x-axis here is our test scores, and then the y-axis is the number of students, and this time it even says frequency for us here. Okay, cool. Moving on to two different types of data sets. Dot plots is the next one we're going to talk about. Dot plots. This displays ungrouped data, so you can see there's like one dot for each data point down here. It's not put in groups like the bar chart is. This is a good way to see the shape of data, and we're about to talk about different shapes of data so that we can recognize those shapes. A dot plot helps us really easily see the shape. For example, here we can see that the data kind of goes in this hill shape, and this hill shape is actually called a normal distribution. In case you were curious, that is called a normal distribution. And yeah, it's just easy to see the shape of data from a dot plot. All right, and then last, pie chart. So, also really quick before we go to pie chart, on dot plots, it's still good to understand like what your x and y axis represent, and that each dot is like its own data point. So, yeah, it's just important to make sure you pay close attention to your x and y axis and what each dot represents in terms of those two things. Okay, pie chart. Pie charts we're all pretty familiar with. They use slices to show the relative size of data compared to the whole group of data. So for example, down here we can see that most people like sci-fi. They actually put a number here, so you can see 6 people like sci-fi compared to all the other ones, types of books. But like you can see the size of the slice is for sci-fi is the biggest slice on the chart. So it's just like a quick way to see compare your data sizes, and like if you look at this whole pie chart, it's really easy to see the smallest slice is biography. So it's just good when you're trying to like really quickly compare the sizes. Okay, so those are our data kind of types of data representations that we'll want to be aware of for SAT. Next, we're going to go over mean, median, and mode, and then do an example. So these are measures of center. So what that means is these things measure like where like the center of our data falls. So first, let's write down the definition of mean. And actually, sorry, measures of center we're about to do. These things differ. We'll talk about like where they fall based on the shape of the data. But let's make sure we remind ourselves what mean, median, and mode mean. Please write these down in your notebook just to help them stick in your mind. So take some notes on these, mean, median, and mode, and I'll tell you how I remember them after I read each one. So the mean is the sum, which means addition, of numbers divided by the total number of numbers. I want you to make sure you write to yourself, the mean is the average. The mean is the average. So mean means average. And we're going to do an example soon on how to find an average of this data set down here. So just wait for that. Median is the middle number when the data is arranged in numerical order. So this one's really important. You've got to make sure you arrange your data in numerical order when you're finding the median. So sometimes the data will be all mixed. And for example, if you had the numbers 1, 7, 3, 5, and 6, to find the median, you would need to arrange these in numerical order. So we want to move the 3, 5, 6, 7, and then the median is the middle number. So it's the number 5. Cool. All right, so I'm going to put that here. Sweet. And then, oops, lost my little arrow thing. Okay. And then the mode is the number that appears most often. So if you have a bunch of numbers, 6, 7, 8, 4, 3, 6, 9, 10, what number appears most often here? The 6, right? So your mode would be 6 in this problem. Your mode would be 6 in that problem. One way I like to remember mode is it starts, or like mode compared to median and mean, is mode starts with the letter M, O, and most often is like the meaning of mode, the number that occurs most often. So that's a good way to remember mode. Okay, let's do an example of mean with a frequency table. So please draw this table in your notebooks because this is a common type of SAT problem, and it's actually a little unique when you have a frequency table and you're finding the mean of your data. So everyone draw this table. All right, now mean is your average. So the mean is going to be, like our definition says, it's the sum or the addition of numbers divided by the total number of numbers. So let's just first add our scores. So here's, or actually let's add the total number of numbers or scores that we have here. So if we want to know the total number of kids who like took this test, for example, these are maybe test scores, we would have to add 5 plus 7 plus 9. So we're like adding these 5 plus 7 plus 9 plus 8, and you would get 29. That's our total number of numbers. So that's going to go in the denominator because we divide by the total number of numbers. So let's go ahead and put that in the denominator. 29 tests total. There's 29 students who took the test. And then the tricky part for a frequency table type mean is that you have, sometimes it would look like you just have 4 scores here. But you don't just have 4 scores. You have 29 scores. So we have a couple options how we can do this. We can write the score 75 times. So we could do like 70 plus 70 plus 70 plus 70 plus 70. And then write the score 87 times. So we'd say plus 80 plus 80 plus dot dot dot. We keep doing this. We can keep doing that. Or we can make our lives easier. And instead of writing 75 times, like what is this the same as? 75 times is the same as 70 times 5. 75 times added 5 times is the same as 70 times 5. So we can do that for all of these. We're going to do 70 times 5, 80 times 7, 82 times 9, and 90 times 8. So you can think of these as multiplying kind of in the numerator with the frequency. But we're adding up the total number of test scores still. So we're going to do 70, and there's 5 people who scored a 70, plus 80, and then there were 7 people who scored an 80. Oops, I don't know why I wrote 70. 7 people who scored an 80, plus 82, and there were 9 people who scored an 82, plus 90, and there were 8 people who scored a 90. Sweet. And when we type this into our calculator, we got to be very, very careful. If you're typing this into a calculator, I would put the entire numerator in parentheses. So you would have like an additional set of parentheses. And then oftentimes it's good to put the whole denominator in parentheses when you're doing a fraction in your calculator. All right, and so our mean for this problem, if you calculate that, you should get 81.655. And you can use a calculator on like that problem specifically. The SAT will make it clear how much problems you can make you can use your calculator on. Okay, cool. So the mean is adding up all of the numbers and then dividing by the total number of numbers. Sweet. All right, let's go over measures of center now. So on the SAT, you may be asked questions regarding the positions of the mean and the median within a data set, and maybe even the mode. So let's look at these different types of data and then talk about where the mean and the median would fall. Mainly the mean and median is what we're going to focus on. All right, so this is important to write down right here. So please write down what I'm highlighting in green. The mean is the best measure of center for data that is roughly symmetric. Okay, so here, symmetric means like if you had a mirror, it would reflect itself perfectly. So let's pretend that this is like a mirror. If that was a mirror and like this was one side, this would be the other side of the mirror, right? Because it matches exactly on each side. So this is considered symmetric data. And it would be useful to have a picture of this in your notes. So I would go ahead and draw the symmetric data in your notes. And this is what's super important about symmetric data. So for symmetric data, the mean is equal to the median. So let's write that down. For symmetric data, the mean equals, I'll do the median in a different color. Actually, let's do here. Sorry, y'all. All right, for symmetric data, the mean equals, and then we'll do the median in, how about blue? The median. Cool. So for this example, like this problem, the mean would equal the median, and they would both be in the middle. So let's draw like the mean and the median now right in the middle. So for symmetric data, the mean and the median would be in the middle. So let's actually make a note. So when your data looks like this, your mean is going to equal your median, and they'll both be in the middle of the data. Sweet. Now let's talk about skewed data. So the median is the best measure of center for skewed data. The median is the best measure of center for skewed data as shown below. Now, we need to understand what skewed left looks like and what skewed right looks like. So please draw these in your notes. Draw these in your notes, and then let's kind of like make a note to ourselves. So skewed left, I like to think of it as they're kind of like opposites. Most of the data, like the tallest bars, are on the right. Right? So I'm going to write most data is on the right. And then skewed right, you can see the tall bars, most of the data is on the left. So this is important to understand and recognize because sometimes questions may ask you which direction the data is skewed. Now, it's also important to know, like before where we drew our like mean and median bars up here, it's important to know where the mean and the median are on skewed data. So let me draw this in and then we'll make like a note to ourselves. So the mean was green, right? On data that's skewed left, the mean is going to be a little bit to the left. So like maybe here would be the mean. And then the median is actually going to be like closer to where all the data is, where like the tall bars are. And then it'll be like the opposite for skewed right data. So the mean will be on the right, and then the median would be again somewhere kind of like towards the tallest or the most amount of data. And remember, this makes sense, right? Because the median is the number that occurs most often. So like these higher numbers occur most often, which is why they're like the taller bars, right? Okay, so let's make a note to ourselves now. For skewed left data, we can say that the mean for skewed left, the mean is less than the median. And remember, you can think of these things as like arrows. Like this less than symbol, you can think of it kind of like an arrow pointing to the left. So the mean is on the left of the median, right? It's left of the median. And then on skewed right, the mean is greater than the median. All right. And all of these things are important to know for SAT success. So please make sure you get all of this in your notebooks, these graphs, and then all of these notes about, or these bar graphs, and then all of these notes about these bar graphs. Understand that you will need to be able to recognize skewed left data where most of the data is on the right, and you'll have to recognize skewed right data where most of your data, your tallest bars, are on the left. Cool. And then yeah, on the SAT, so this just explains on the SAT, you may be asked questions regarding the positions of the mean and the median within a data set. So it might give you like one of these bar graphs and say, hey, is the mean greater than or less than the median? And you'll have to know like, oh, this data skewed right. So the mean is greater than the median. Cool. So I would study this. All right. And oh, it's also important to just like note, we already wrote this down, but for symmetric data, so like that first example, the mean and the median are always going to be the same. So like they're actually equal. These should be like on top of each other. I just like couldn't draw them on top of each other because then you wouldn't see one of them, but they're right in the middle and they equal each other. All right. And this just like summarizes what we already wrote down. Cool. So that's notes for today. Now you're going to take these notes and go practice.